Welcome back to the class 5, lecture 5. In this lecture, we are going to talk about the design problem. Okay, the general design problem. As you can see from the figure, that this is a 5-stage proactive new product development process. In the previous lecture, we have finished the stage 1 opportunity identification. This time we are going to talk about the design part. Okay, it will involve a series of consumer research and engineering. Okay, it will be quite interesting. And today's I'm going to give you an overview. Okay, now there is a interesting story talking about how communication can be distorted, and in a business setting. Look, for example, this is the product defined by marketing department. Okay, it looks like, what does it look like to you? A swing, right? Okay, and then this is what the salespeople order the product to be manufactured. Okay, that's the sales order. See, now from marketing to sales order, it's already different. Then the engineer, after receiving the sales order, engineer designed the product this way. Okay, some of you may start laughing. Then the manufacturing produced the product that way. Okay, and the field engineer install the product this way. How many of you have not start laughing? I too laugh too. Each time I look at this, I really found that this is quite ionic. Look, what actually customer want? What actually customer want? This is what actually customer want. A very simple swing. Alright, this portray the severe distortion of communication, and that happens in many settings, including in business setting. Alright, therefore, for design, in design stage, we must be very careful about what we communicate. That's we get into this kind of funny problem, right? Okay, so design problem begin with identifying the key benefits. What are the key benefits that our target customers they are desiring? Hence, our new product should be carrying. Okay, then also we need to pay attention to how do we position our products versus competing product, and satisfying the psychological demand and requirement. Then the new product design should carry the product after designed, should carry the properties, features, and so on to fulfill the promised benefits that required by the market. Okay, this figure show the general design process. And as you can see from the upper left-hand corner, that's opportunity identification stage. Stage 1, we have just finished that. Now it enter into the design stage, which begin with we need to measure, to do research from our customer, including consumer customer and business customer alike. Those research can include qualitative. Okay, identify what are issues that concern relevant, and then also we can do the quantitative research to identify the input levels. Okay, yeah, and typically we do this through survey, and of course we can also do this through in our interview, focus group, etc. After we measure our the input, measure the issue, understanding customers' needs and wants and so on, the preference, desire, and so on, then we enter into the models which help us to visualize what our consumers think about the products, brands available in the market. We do this through perceptual mapping. Okay, and also we analyze customers' preferences by preference analysis, and then also we determine which segments should be our target segments. Then for that, we will devise a best strategy to serve them, and also see how we also predict ensure the purchase of the products that will be likely from our consumers' choices. Then we predict the market behavior from individual to aggregate level, adjust for the awareness and the availability level. Through this, if the result is satisfactory, then we evaluate that. If it is satisfactory, we move the product to testing. Otherwise, if mediocre, then we set it on to refine the marketing, R&D, engineering, production plan. And refine it, redo the loop again until it go back for evaluation. If it's truly a bit not going to make it, then it's no go. We just drop it. And for those who after test, we will further define its core benefit proposition. Choose the best core benefit proposition, CBP. Then we introduce the product into the market. So here it actually not only talk about the design stage, it also include the testing and later on. All right, good. Hope this diagram provides you with a good overview of what will be included inside the design process. Before we get into the detail of design process, let me explain to you about the experience of Ch05. Ch05 is a General Electric and the Fujitsu automation numerical control machine companies. That's a joint venture between the famous American and the famous Japanese companies. Their experience shows this. If the product idea is from inside the company versus from outside the companies, what would be its successful rate? The successful rate for from inside the companies versus from outside. Anyone has a guess? Just make a guess. Surprisingly, it's 1% versus 56%. It's even for me. It's a surprise. I know that outside in typically would be more likely to be successful because we obtain the information from outside. And however, this difference is still surprising to me. All right, the designing a product oftentimes whether when should we set the budget? If we set the budget before new product development, manufacturing process, and then the design new product to meet the cost constraint, this way, will generate one kind of let me show you here. In United States, typically we do market research, then we specify the product characteristic, then we design the detailed specification through engineering, calculate the supply cost and the total cost. Then through manufacturing, we periodically launch some way to reduce the cost. And sometimes if the cost is too high, we return to design place and the loop until the cost fit the target. This is the left hand side. This is the way that we do here usually in this country. And how about how Japanese keep their costs so low? Because after their market research and product characteristic, they start planning their sale price first. They think about for the focal new product, what if the sales price is set within at specific level, then the product would fly. Otherwise may not be. So they use this plan the sale price to less the desired profit that become the target cost. So the target cost cannot be above this, and this target cost actually as a central control for design, engineering, and suppliers, price of the raw materials and so on and so forth. Okay, then go through the manufacturing and the continuous cost reductions also. Look, the difference between these two is they can identify the cost early on, which guide the rest of the design process. Hence, after product is designed, the likelihood 1-for-1 you will shorten the product design process. Second, the product design would be more likely be successful. Okay. Now, there's another principle called simpler the better. Okay, let's look at Swatch example. We all know Swatch is the abbreviation of Swiss watch, and we also agree that we know that Switzerland is famous in its precision mechanics and particularly watch industry, right? Rolex, those kinds. Swatch is different from traditional Swiss watch. It come out with a new concept. For those who use the Swatch or are familiar with this brand name, the product in this brand name, you can confirm so that Swatch is designed with very few parts. Okay, and also with, of course, so-called the trendy, appearance design. The thing is this: when we have fewer parts, then the supply costs reduce. Also, user costs reduce. Why? Because fewer the parts, the lower the probability that you will be, broken. And even when it's broken, it's easier to fix. So the maintenance cost is lower, right? On the other hand, US products are famous in too many features, or so-called over features. I used to have a PhD student working with me at University of Illinois, where I used to teach. Then she and I did a research and identified that the US-made products carry too many features. Give you an example. For those VCR, okay, when still with VCR at the time. Now we use DVD, right? By the time we use VCR, the VCR manufacturer will say, "Oh, our VCR is capable of providing 180 channels, and it's much better than those with only 99 or 110 channels." All right, seems to be much capable. So people, buyers, pay extra dollars, okay, higher price for this new product. But tell me, how many channels actually do we watch? 100? No, right? Yeah, very limited number of the channel, and those extra capacity actually are unused, right? Think about another example. We buy a lot of electronic products, and they have hundreds of different features, different functions. But how many functions do we use? Look at your radio clock. How many functions do we use? Clock, alarm, right? Yeah, your radio. That's all, right? And actually, to the point that so many features actually becoming a burden. Every year, when we have the daylight saving change in the spring, in the fall, in your household, there are more than 10, 20, 30 different places that you have to adjust the clock, right? Don't you? And that's very. Some of them are quite straightforward, but many of them are very difficult. You don't even know how to cancel the alarm. Nowadays, for example, in my home, 12 a.m. I should say, 12 a.m. While we were just about to nodding into sleep, the alarm, clock, start alarming, and now we have to wait for our daughter to come back to figure out how to get rid of the things. Yeah, I'm pretty techy person. I was an engineer, but still, the products are too many feature. Okay. Another story here I list is Andy Grove versus Stan Shi. I mentioned to you Stan Shi, the ex-CEO of Acer from Taiwan. And Andy Grove was the ex-CEO of Intel. You know Intel, the CPU, the king, the CPU, manufacturer, most famous globally. 1996, I went back to visit Taiwan to give a lecture during the summer. My junior from the engineering college, he was vice president of consumer products for Acer under Stan Shi. He invited me to attend meetings in Taipei. That was the Acer's Global Distributors Conference. Okay, so about 2,000 or so selected distributors who distribute Acer's products from around the world were treated very nicely to have a conference in Taipei. And in the same meeting, do you know who were also there? Bill Gates of Microsoft. He was there. Okay, and another gentleman, I think he was the CEO of Sun System. Yeah, a Japanese descendant, I think. So Stan Shi, Bill Gates, and this gentleman, I forgot his name. Three of them stand in the stage, while Andy Grove was in America, and they have the 4-person conference right on the stage, and Andy Grove through the teleconference. So his face shown in the huge, gigantic screen, so people can see him, and I believe he can see other people from his side. And I was among the audience. There was a debate between Stan Shi and Andy Grove. What was the debate? Stan Shi mentioned to these three gentlemen, two just beside him physically, the other one through the information technology, Andy Grove, saying that he was envision the personal computer has to be under $500, okay, for the third world. And Andy Grove got very upset. He said, "Stan, this is crazy. Think about my CPU, the Pentium 2, Pentium 3." Then he said that it costs $300-400. How can you provide computers under $500? Yeah, and Andy Grove was upset by the Stan Shi's low price strategy, but Stan Shi said that Andy, if we wanted to continue doing the business, we need to start thinking about those third world countries, including China and India. Okay, you name it. Just name those two. Together, these two countries has about almost 40% of the world population. And they develop very fast. Okay, if we don't do it, somebody else may do it. I don't remember what response the other two gentlemen, that Bill Gates and the Sun Systems presidents was saying, but I remember Andy Grove and Stan Shi debate right on stage. What happened is, just a year after that, I believe 1997, IBM started introducing their PC under $1,000, 990 something. In 1996, at the time these people were talking to each other, the average price of PC was $1,500 to $2,000, and the laptop was even higher than that. But class, think about, okay, just barely a year later, the price dropped to under $1,000. Nowadays, how much does it cost? You know that. For desktop, $200-300, right? Plus the monitor. For laptop, now we can get many laptop under 1,000, right? And so the Stan Shi's vision of providing the products with under $500 actually was it become true, right? Okay, but by saying so doesn't mean Andy Grove was wrong. It's just different vision. Okay, but US products famous in too many features. All right, now we talk about the parallel versus sequential process in our previous lectures, which derived from Takeuchi and Nonaka, two Japanese scholars. Okay, and this diagram I showed you before, if you recall, that's the A is traditional, sequential, step by step. B is they have overlap. C has very deep overlap. So total product life cycles decrease. Therefore, when we're designing a product, we may start designing way before the opportunity identification stage was over. Okay, there are a few things help us to do the design more effectively, even automatically. Okay, the one is we have the technology building blocks. Okay, which means, look, nowadays we have so many things going on, and some finished products, they include multiple existing technology that been used elsewhere successfully. And if we have the database to pull all those technology building blocks together, it's like we are building some new project, like using the Lego, right? The children use Lego to build up their castle, the ship, the truck, and so on, right? Yeah, each existing technology can be considered as a building block. So we can have an existing design plus some additional new design, then let this to the new products. Okay, and it will be as easy as building Lego. Okay. Also, we need to test the design effectiveness. Oftentimes, now I'm talking about the Ch05. That's what they did. Okay, and we can learn from them. Okay, they use minimum 6 months. They will monitor customers' response. Once they have the product design, they will show to the customer. All right, now with this experience from Ch05, there's another useful tools that one can use for your effective designing. It's an inventive ideas grow on the trees. Okay, grow on trees. This is from an Ideation International Incorporation. I think it's in California, and run by Russian scientists. Okay, Russian scientists. I will explain to you what they have to do. Okay, what they have. Typically, this trees concept consider individual has his or her personal knowledge. That's most inside, right? The blue color one. Then within a company there are multiple individuals. If we pull every individual's knowledge together, we form the knowledge within the company. That's the yellow over. And if we pull the knowledge of each companies across multiple companies within a certain industry, that become the knowledge within that industry. That's orange color, right? And then throughout the society there are multiple industries. If we pull all those knowledge together, we have the knowledge throughout society, the pink color, right? And then this society, that society, different country, different society, if we pull all them together, that become the last one. Okay, all that is knowable that we know. Okay, that's the idea of the knowledge. Interesting enough, this seems to be parallel with the internet, right? Internet actually is like similar to this one. Okay, every library has its own collection. If the collection through digitized, okay, electronified, then we can exchange information through the information highway. Anywhere, anytime in the world, you can get information desired from anywhere, any part of the world. If they are on the, if they are linked with this system. Similarly, the internet information highway makes this even more more efficient and more feasible. Okay. This company is pull 400,000 ideas from worldwide patents because they focus on inventive ideas. So they pull the worldwide patents, okay, on fire. They choose 400,000 ideas. That's quite a lot, isn't it? Okay. And how trees works? Trees work like this. From the left hand side, you have your problem, right? Assuming this is my problem. Okay. From the prism of trees is this: decompose the problem into many standard problem, like the light, right? The sunlight through through the trees. Yeah, it come out with 7 different color, right? Okay, then each standard problem has its standard solution. So when we decompose our unique problem into many standard problem through the information idea database, we can match with whatever required matched compatible standard solution. Then if we recompose this standard solution, that become our solution for our problem. Make sense? Okay. The trees model, it's by this company. They use the innovation workbench system as a software to handle the process that just mentioned in previous slide. And it looks like a spaghetti and meatball, right? A problem through situation questionnaire, we navigating it and reformulate, and so on and so forth. Finally, we find what we need. Okay, and of course, the procedure can be complicated, but with the powerful, computational technology and capability equipment we have, now this become less, troublesome. Okay, right. Now, their results show that most of the improvements are small improvement of existing system. Okay, that's this. How would you like to call this color on the right hand side, or anyway, right? And then, if you look at the bottom, the discovery or pioneer invention of a new system is the blue color. Is very small percentage. Yeah. So anyway, this shows that it's consistent with our observation. Small improvements are more frequent, and the discovery, pioneer inventions are just a few, but they are still useful. Now, continue for this trees mechanism or the methodology. Yeah, the Genrich Alschuler, this gentleman, he provided 40 inventive principles, including segmentation, extraction, local equality, asymmetries, feedback, and so on and so forth. Now let's look at one of them, number 4, asymmetry, which I use different color and a star to attract your attention. Think about the asymmetry. How many of you ever replace your flat tire? If your tire get flat, some of you may, some of you may not. Look, sometimes the tire get flat is because of the the road hazards, right? Some nail and those sharp things, sharp objects penetrate through. But sometimes it's because the tire hit the curb, and hit the curb so hard, and it damage. We know the tire typically is a what? The tire is a round shape if we see from the sideway. But if we see from the front and rear way, it's a like a rectangular, right? Okay, and the both sides are symmetric. But look, if a tire is designed to have one side which has thicker material to protect the tire against the impact, from the impact against the curb, that will help reducing a lot of tire damage. So that's one side of the tire is stronger to withstand the impact with the curb. Yeah, and if you pay attention to now, more and more tire companies produce this kind of tire, which are asymmetry. Okay, it's against our general perception, general concept about this perfect, almost perfect round shape and on both sides are symmetrical design, but asymmetry has its benefit, right? So seeing something different from traditional one oftentimes, it's useful. Then also it provides the 39 engineering parameters, including the weights, improve the weight, change the weight of the moving objects, of non-moving object, the length, the width, you name it. Okay, now just see this weight of moving object. Yeah. How many of you have this experience seeing the children using the toys that you were never fall or non-stumbling? Okay, and the children push it and you will come back and stand up again. How does it do so? It's because they add a lot of weight at the bottom of that that door, okay, or that figure. Okay, even you punch it, you will fall down, but you will immediately, because of gravity, will stand up back again, right? Those are example. Now, the putting these two things together, okay, we mesh it, okay, then it will help us to propose the possible solution, okay. And the article actually talk about a lot of detail, and for the sake of the clarity, I would encourage, if someone interested in getting into that, check that out from the internet. Okay. Now, the design testing loop looks like this. It has two parts: marketing part and the R&D engineering part. When the new product concept is defined, that's in the center, concept already developed, then marketing will initiate the analysis and the screen from the environment, getting it to the market to see how market responds to it. Okay, so and how do they dislike, and screen out those not so well designed products. On the other hand, R&D function will initiate to further develop the concept into prototype. Prototype is the products carry all the function, the major function, right? But it's not coming from the mass production. Okay, it's like a sample, a functional, workable sample. So R&D will initiate fabrication of prototype and to follow the specification, develop further, and testing the products, oftentimes inside the laboratory, the R&D engineering department, to see whether those material, the specification meet the desire, the planned specification, the material property, physical property, chemical property, or whatever property you name it that can be tested in the engineering R&D department. Then, in addition to that, marketing peoples, because they are constantly doing the environmental analysis and screening, can request the prototype to be placed into the market, or to be encountered with potential users, buyers, customer, and see how they respond, and use that information as the feedback for further modification, improvements. Okay, for R&D to do the further modification and improvement. Okay, so this consists of the design and testing loop. Okay, now quality functional deployment is a concept that's very useful, and it's consistent with our typical design process. Now I'm using the quality functional deployment of a microphone as an example to show how it can be useful in the design stage. Look, for example, if as a marketing from marketing research, we identify the customers, they prefer the microphone looks cute. Then what makes the microphone looks cute? One, perhaps its size, right? Smaller the better. Of course, you cannot be too small. Too small, you can easily drop it lose it or even swallow it, right? Just a joke. Another thing is the color, right? Black, white, or silver, or you name it, some other color, right? Which color make it look cute? Which size make it look cute? Okay, and the shape, right? Different shape. Which shape make it look cute? There may be several different shape. So from here we derive, okay, our product design, okay, from abstract level, which is cute, right? Cuteness, to the size, to color, to shape, and maybe some other things that are not included here. That together will make this product look cute, this microphone look cute, right? Also, another things that marketing research show that the market like the microphone to be convenient when using. Okay, so what make it convenient? Right? If it can be used in different places, it can be used in the car with a PC, for example, right? Anyone ever had experienced that microphone used in a car? Not that prevalent in this part of the world, but if you go to Asia, particularly if you go to Japan, Japanese people and the other part of Asia as well, after Japan has this fever. That's karaoke. We say karaoke in the United States. Actually, Japanese pronunciation is karaoke. Okay, karaoke. As they sing along, right? We say sing along. Okay. And they sing along not only at home, not only at restaurant, at the bar, even in the car. Many years ago, when I visit Tokyo, I hop on a taxi, and the taxi driver gave me a microphone and say, "Okyaku-san," which means the customer, the honorable customer, please sing, if you like. What a surprise! And so the microphone can be used in the car, and if it is used in the car, perhaps you don't want to use those wire cable one. Why? Oh, the cable one, it can entangle, and maybe just a joke, okay? It can strangle the driver, then that would be dangerous, right? When you sing so happily in the back seat and forget about that the driver is in front of you, right? So wireless can be useful, can be important, and then easy to carry. If it is easy to carry, the size has to be certain limit. The shape has to be easy, right? For example, you can put them easily into your pocket, all right? And the battery has to be if battery is rechargeable, it's easier. You don't have to plug the thing in, right? Into the power plug all the time. Okay, all those are some example that how design will be required to make it convenient. Make sense, class? There are something else not included here, but just those are just some example, right? And then sound effect. Okay, people like the sound quality to be excellent. So the regular people like you and I, after using the microphone, we sing like Elvis Presley or like whoever famous star, right? Okay, so stereo system, surround sound system, and we change the tone, right? To fit individuals' needs. Those will be some example that deriving from the quality required, the benefit required to more concrete level of the product design. All right. Any question? Good. If not, this conclude our lecture 5, the design problem.